Now let's look at an example where we're integrating x squared over x minus 5 times x minus 6 quantity squared. So again, a rational function where the degree of the denominator is larger than the degree of the numerator. So let's decompose this rational function. So we have x squared over x minus 5 times x minus 6 squared. And here we notice we have a linear factor, and we have this linear factor here, but it's repeated because we have the power of 2. So that means we'll have a constant over the linear factor x minus 5, we'll have a constant over the linear factor x minus 6, and we'll have a constant over the linear factor x minus 6 squared. So now we have three constants that we need to find. If we put these over a common denominator, that common denominator will be just x minus 5 times x minus 6 quantity squared, and the numerator will then be a times x minus 6 squared plus b times x minus 5 times x minus 6 plus c times x minus 5. And now we see that we have this numerator here has to be the same as this numerator here since they have the same denominator. So that means that x squared equals a times x minus 6 squared plus b times x minus 5 times x minus 6 plus c times x minus 5. Now the question becomes, how do we solve for a, b, and c? And let's see if there are some choices for x that will help us. Well, if we let x equal 6, that will knock out a, and it will also knock out b, so we'll end up with 36 equals c. Then we can choose x equal to 5. So if we let x equal to 5, on the left-hand side, we'll have 25. And on the right-hand side, we'll have a and just a. So that means that a is 25. Now to find b, we need to choose another value of x different than 5 and 6. And one of the easiest ones to choose would be x equal to 0. So if we let x equal to 0, then on the left-hand side we just have 0. On the right-hand side we have 36a plus 30b minus 5c. Now since we know the values of a and c, we can use those to find b. So if we substitute in a equals 25, and c equals 36, we get that b equals negative 24. Another way to find b is by looking at and matching the coefficients of like terms on the left-hand side of the equation and the right-hand side of the equation. So on the left-hand side of the equation, the coefficient of x squared is 1. That means that 1 has to be the coefficient of x squared on the right-hand side of the equation. And on the right-hand side of the equation, we see that the coefficient of x squared is going to be a plus b. So now, since we know that a is 25, then we can also conclude the same thing, that b is negative 24. So those are two ways that you can find the constant. So now we have that the integral of x squared over x minus 5 times x minus 6 squared is going to be the integral of a over x minus 5, where a was 25, so it'll be 25 over x minus 5, plus b over x minus 6, where b was negative 24, plus c, which was 36, over x minus 6 quantity squared. And these are now all terms that we know how to find the antiderivatives of. So this first term will be 25 times the natural log of the absolute value of x minus 5. This term here will have an antiderivative of negative 24, the natural log of absolute x minus 6. And now for this piece right here, we'll just do a little u substitution off to the side. If we let u equal x minus 6, then we have that du equals dx, and what we're then integrating is 36 over u squared. And that will be the same as integrating 36 times u to the minus 2 power, which will be minus 1 over u. So this will be minus 36 over u, plus some constant of integration. And then, since u is x minus 6, this will be minus 36 over x minus 6. So this final term will integrate as minus 36 over x minus 6, plus your constant of integration.